Has everybody exchanged their quiz papers? Okay, is there anybody who wants me to grade their quiz paper? All right, then make sure you have your name on the bottom of the quiz paper you're grading. Huh? You have a hand? Oh.
Okay, right for
What? Yes, give me yours and I'll grade it.
If like they didn't draw the chart, and like when you're doing like your corrections, should we draw the chart for them?
Whatever I put down here, that they don't have, you need to put down because that's correcting their paper.
Even the charts.
Yeah, what your goal should be to not just grade their paper, but to correct it in a way that gives them everything they're going to need to be successful in the test when that comes around. Okay? Yes.
If they have like if they balance it but they don't have the classification, how many points do you?
Well, let's go through the whole thing and then we'll decide how we're going to split up the points, okay? All right. So number one, we have AgNO3. And I've got that shown as being aqueous. And I have Al, which I show as being a solid. Okay? So what we have is an element that's by itself and an element in the compound that it's like in a sense that this is a metal and that's a metal. So it's possible that aluminum could displace silver. We have to figure out whether that will happen, and for that you need your test references. I want to be able to show you what I'm looking at when I make these judgments. Okay, so because I have a metal that's by itself and a metal in this compound, it's possible for this to be single replacement. I'm going to go ahead and classify this as single replacement or single displacement. Either term is acceptable. And that's what we use the activity series of metals for. So what I want to know is the metal that's by itself, is it higher than the metal that's in the compound? If it is, it will displace the metal in the compound. So I'm going to look for aluminum, and there is aluminum. And I'm going to look for silver, and there's silver. So aluminum is higher on this list. It's above on the list, silver. Not above on the periodic table, but above on the list, silver. So it will displace silver. Yes, ma'am? All you have to know is whether lithium is above rubidium and potassium, and if it's higher on the chart, it will displace something that's like in the compound. So when we're looking at silver, silver is really an ion of silver. This is an ionic compound. And so this is actually Ag1+. So this aluminum up here is higher than the silver down here. So the aluminum will displace the silver. So we have a driving force for this reaction. That's all there is to reading it. Okay? So aluminum will displace silver. So what we're going to do is go over to the other side. We're going to put aluminum with the back part of the compound. Okay? Now I have not balanced the compound yet. I'm just simply putting things over here at the moment. Do you want someone to grade your quiz, or you want me to grade it?
I'm going to do it.
Huh?
I thought Emma do it.
Oh, okay. Who has? All right. So you have Amber's paper? Okay. All right. Since aluminum displaced the silver is now by itself. Okay? A metal that's by itself is almost always a solid. The only exception is mercury that you should know about. There is at least one other exception. It's not very well focused, is it? Is that a little better? Okay. And then we need to figure out what physical state this is going to be in. We can see that nitrates are soluble. They're soluble only if there's water around. Okay, so soluble means this is what it can do. Aqueous means that's what it does, and it does it if there's water around, and since the silver nitrate was aqueous, there is water around, so this will be aqueous. Okay? Alright, now we have to balance the formula. Aluminum has a 3+ charge, so when aluminum displaces something, it becomes aluminum 3+. There's the aluminum 3+ there, or you could look it up on the periodic table with oxidation numbers. But for single replacement reaction, it's probably better to use this. So since aluminum is 3+, and nitrate, you find out on the, well, let's do this. Aluminum is 3+, and nitrate we find on the common ions list. It is 1 negative, that's true. Okay, let's see, where's nitrate? There it is right there, there's nitrate. Okay, so it's 1 negative. You will need 3 of those. So you have a 3+ here and a 1 negative here. And we want to know how to make this equation work out to be 0 overall. So we're going to need 1 aluminum and 3 nitrates. Okay, so we need a parentheses around the nitrate and a subscript 3 there. Okay? Now that we have all the equations balanced, we can balance now that we have all the formulas balanced, we can balance the equation. And for that, we're going to use an atom inventory. I'm going to write down all the elements in the equation in a kind of spreadsheet. And count all the elements on the left side and count all the elements on the right side. So I see that I have 1 silver, 1 nitrogen, 3 oxygens, and 1 aluminum on the left. On the right, I have 1 aluminum. This 3 outside the parentheses means I have 3 nitrogens. And the 3 outside the parentheses means I have 3 times 3, or 9 oxygens. And I've got 1 silver. We always balance oxygen last. So the only thing to balance it, at least in the beginning here, is this nitrogen. Since I have 3 nitrogens on the right side, I need to get 3 nitrogens on the left side, and the way to do that is with coefficients. Once all the formulas are balanced, we can't put any more subscripts. We can't change the subscripts. We can only use coefficients to balance equations. So I'll put a 3 here. That's going to give me 3 silvers. It's going to give me 3 nitrogens. 3 multiplies everything that's in the formula. And so since I have 3 oxygens here, it's going to give me 3 times 3, or 9 oxygens. Okay, so right now everything is already balanced except the silver. And all I need is a 3 here in front of the silver, and the whole equation is balanced. Okay? They didn't finish this over. They had the right initial atom inventory, but not the final atom inventory. Well, let's do this. We're going to give 1 point for having the correct identification of the type of equation.
It's only 1 point.
This is going to be a 12-point quiz. We're going to give 1 point for having the correctly balanced, predicted and balanced formula here.
You mean like before you add the numbers in to balance it out?
No, if everything's right, it's worth a point. Okay? We're going to have 1 point for the correct and complete atom inventory. and we're going to have 1 point for the correct and complete balanced chemical equation.
So you don't get anything for having like the original right with like the right order and everything?
And this is the point scheme we're going to use for this quiz. Okay? So the whole thing total is going to be worth 4 points. Okay?